equals to median equals to mode, isn't it? Inferential statistics. Okay. Now, I hope it's a good or not. I hope everybody's understand this one. So it's fantastic. Good, Yamini. Good job. And okay, so inferential central limit theorem. So I want everybody to download. And Yamini, please, you can also update in your LinkedIn about this. I mean, till stats, all those things. ANOVA analysis of variance. Where do we find this ANOVA in practical, guys? Where do we find this in practical? In regression stable. In a regression stable, isn't it? We find this in regression stable. Okay. I mean, she made for this team. That means she update in the group. You can download and review all the formula. Whenever in the interview, recall this formula, speak more about the concepts and clear that rounds. Understand, guys? Advanced statistics, PCA, very component analysis, how to find out covariance metrics, and how to find out the eigenvalue eigenvectors, chi-square test, very good. Linear regressions, multiple linear regressions, so you can, yeah, many like loss functions, cost functions, add another one slides equals to, or maybe here see loss functions equals to cost functions. Okay. And polynomial normalizations, very good. Just add also this, and the ranging between 0 to, yeah, so just 2 to 3 pages of changes. Very good. X minus mu, this is also called G score. Okay. And bias variance, very good, guys. So all those things we done. From tomorrow onwards, there's a lot of, I'm going to already start classifications today. Good job, guys. Excellent work, Yamini. Please continue till last, and please download the formula sheets. Okay. And you keep it yourself. You keep for yourself as a reference. Okay. You keep this sheet as your references, guys. I hope understand. Are you clear or not? Okay. So today I will go ahead and introduce my ranking table. Yes, I do see the ranking table, but I found some of them are incorrect. Just one moment. Let me unmute you, Yamini. And when I see this,
Yes, sir.
why you got 777? Did you see? Because we have the salaries, we have how much? 3 lakh.
Yes,
Yes,
sir.
Yamini? Yes, guys,
Yes.
3 lakhs. So when you have 777, this is, I mean,
Yeah.
this is not make sense. And didn't you want, you should change the estimate to reduce to like 10, 15. As I said, you need to pass random state equal to 0 parameters in forest. You try, all these accuracy will scale down to less than 300. Just you need to add random state 1 equal to 0.
Okay,
And
sir.
I do see this is completely
Yeah.
wrong,
Yes, sir.
because I don't find everything is equal, even though change the square roots. And no, KNN, this is too something. You restart the kernel, maybe you're not this is perfect. I
Yeah.
agree to, I agree to this, and a little bit work on it and update once again. Okay.
Okay, sir.
Good work.
Sure, sir.
Yeah.
Sure, sir. Thank you,
Anybody
sir.
got this, guys? Anybody build the ranking table? Anybody build the ranking table? Good work. Thank you. And Yamini, please maintain the formula sheet still last day. Even the deep learning neural network, we have a lot of formulas. Even the open CV, also we have formula. And please maintain that. Okay. And I would request everybody to please download the formula sheets which prepared by her. And yeah, so please maintain. For you also, that is applicable. Okay, guys, let's continue today's sessions. And before today's sound, that sound is clear or not clear? Please get in. Good. Now you check something from your side. Okay. Sunday and weekend starts, and I want you to let you know my 2 of students are placed, and let me show them to talk to you, to introductions with you, to find you. Like, I mean, she was mentor, she was non-technical, learned listen the it. And being a fresher, she picked the package of almost like 6 lakhs per annum as a junior machine learning engineer. Before I go ahead, what she make resumes and how she get placed, and let's have a look at it. And I just call her to talk to you because she's flying to Bangalore, and I'll show this offer as well, guys. Okay, and I will directly go ahead. Okay, I so this is what. Sorry, just one moment. Okay, open when done. Off. So 11th May. Okay, the name of the company is Monte Corps, and the designation which 6 lakh CTC per annum. Understand? And I think it's located, it's World Trade Center at Bangalore. And I see the positions. Control F. Okay. Did you see junior machine learning engineer? What we call junior machine learning engineer. Now let's scroll in hand. This is what being a fresher, she will get up these much of packages, guys. All right. In hand, I think 43 something like that. But at end of the day, she will get maybe allowances and all those things. Are you clear? This is one offer. And before that, what the resume been prepared for her on. So I made the resume like this. And what are the projects? What are the in her? I will show this out. Just one moment. Okay, so MTech from IIT, and that's also not something. And so all those things technical mention Python basic R programming, MySQL, whatever I taught you in the class, same things have been mentions. And then algorithms, what we covered, projects, sentiment analysis, default risk analysis. I gave you churn and cotton disease predictions, and MTech development of modify MN steels, prediction of mechanical properties of steel using. She is not an IT, so I recommend to add this statement. Look at this. After tuning parameters, the performance of the matrix linear regressions 97, 91. So guys, whatever I'm explaining you, same things they've been mentioned in the profile, and you get interview calls or not. Are you guys understand? Yes, team, everybody, online team, are you there? So fantastic resume, and I want you to maintain this one. And my other student, she's a lawyer, okay, and or also got placed to the same company. And just one moment, for the same company, I had some of the references. I referred good that one rejected, two shortlisted, and two got placed. Right. So this is also same offer with same designations. This is also same offer, and her name is Varka. And just close this. What type of resume she prepared? She prepared completely fresher resume. Just one moment. I want to show them up as well. Okay. Did you see? Look at the resume styles or not from one student to other student. It's not that resume has to be copied and pasted. Yeah. So all those things, and customer churn for Bank of Springfield, and mention risk management. Okay. Future predictions for risk management factors. The two projects, that's it. And that's it, guys. And she got placed as, I mean, she had 7 to 8 years career gap. She was lawyer before. I tried to put him on online, but I didn't. I didn't speak with her. Once I get time, I'll speak and invite her to talk to you. Because the reason why, whenever the student placed, then on discussion I owned. You wanted to talk, or I will continue the sessions, guys? So I will invite at least one so that you listen how exactly they struggled. I do understand when you're learning this code, sometimes you're down, sometimes you're up, isn't it? So what is it? I mean, motivates you. So let's understand. But before that, today we talk about very important sessions. Look at the placement. When the batch is started, how what is the placement, guys? I think 38, something like that. Yes. Now within 2.5 months, this is or increased or not? Increased or not? By the time batch is complete, it will be expand. Maybe some of your name has to be printed here, and all of them is not fake. Very simple. Learn the class, practice, give interviews till the time you get placed. That's only one solution. So today I will talk about very important topic today, last class of regressions, and this we call regularization technique. What we call, guys? A regularization technique. What is meant by regularizations? Regularizations means we have three technique: lasso regressions and ridge regressions and elastic net regressions, guys. What we have: lasso, ridge, and elastic net. Lasso we have L1, and ridge we have L2, and elastic is L2. Are you understand, team? So lasso regressions or lasso regularize. So do you remember what is overfitting? If we train the model with more attributes, then overfitting problem comes up. So to reduce the overfitting, what we do? How? Let's understand today. Let's understand today. I will quit. And before that equations, I hope I'll write one form plus 10x1 plus 39x2, isn't it? So when I say, can you please tell me out of these three, which independent variable has the highest correlations to the dependent variable? Which independent variable coefficients are highest correlation with dependent variable? X2. Great, X2, isn't it? And then what else? One, isn't it? I mean to say that what is regularizations will do, the regularization will reduce the magnitude of high coefficient to low coefficient. What exactly I'm saying? High coefficient to low coefficients to reduce overfitting problem. I mean to say that what is meant by that? Just one moment. Eighth. Okay. Now ridge regressions. So guys, maybe these images are blur, but it has makes more sense. Understand, guys? Look at this. Here, I have 0.9, 1.2x1, 20x2, 39x3. Isn't it? How many independent variable we have? Three. X1, x2, x3. And then we have two regularization functions. One is ridge, one is lasso. The formula of the ridge regularization is loss functions plus penalty. Loss functions. If you understand this, whenever we do any model, there is a parameter called L1, L2. So you must need to tune these parameters. What is loss functions, guys? What is loss function? To difference between actual minus predicted or not? Loss functions mean difference between actual and predicted. So this is loss functions, right? So this is loss plus penalty. What is penalty? W1, W means this weight of these records. What exactly we call, guys? weight of these records, penalty. What is mean by penalty? Because of you, someone get hurted, you pay some price to compensate the penalty or not, guys? So the same way here, the loss functions plus penalty. So what this is called regressions. When you apply what is meant by regularizations, it reduce the high coefficient. For example, I'll give you one 2, 3. You said 6, isn't it? And next one, 20 into 30, you said 600. Next one, 15 into 10, you say 150. But when I say 999 to 99, will you explain me? Will you explain this, guys? Not possible. So what you do, you will take a calculator or not? So when I give you high task, your brain cannot functions, isn't it? So this is called assume. I give you an example. High computations, you cannot. You need to someone help, isn't it? But when I say 15 into 30, you immediately isn't the same way here. What exactly happen? Ridge regressions, it will reduce the coefficients to, I mean, high coefficients to low or it's reduce the magnitude of independent variable coefficients to reduce the lowest one. But what happens if you apply the ridge regularizations, it will scale down 39 to 5 and 20 to 2 and 12 to 0.7. Are you guys understand or not? Are you guys understand? So this, when there is a chance of reduce overfitting, there is a chance of reduce. Anybody's there? No, there is a chance of reduce overfitting problem, guys. Are you understand or not? So I hope you're clear. So let's talk about this one. What exactly regularizations, guys? So regularizations use the coefficient of which variables? Dependent variable. It reduces the coefficient of independent variable, isn't it? So regularizations, we have ridge regularization, or also we called as ridge regression, or we call L1 or L2, guys? L2. L1 or L2? L2. So what exactly L2? It's the coefficient from high magnitude to low magnitude. What is meant by that? It changed the 12 to, it reduced to maybe 35 to 5, 35 to 7. Are you getting me? So this is called ridge. I will explain all those things, no need to worry. So this is all ridge regularizations. The next one, we have lasso. The next one, what is the formula, guys? Ridge regressions? Loss plus penalty. In the penalty, are we using square or not? Have a look at this. We are using square. Did you see? Loss plus penalty. Are you getting me? What loss functions? Gradient loss. What is gradient descent? We try to reach the global minima, okay, with the step, I mean, what we call momentum, like learning rate. So just go back. This is ridge, and let's heading to a lasso. So what is meant by lasso? If you compare ridge and lasso, do you find any differences or not? What find difference? No square is found here. When you don't have any square in this formula, what happened? This is also the formula here. Look at this. 39 had scaled down to 5, isn't it? 20 had scaled down to 0. 1.2 had scaled down to 0. When can I write down 0.9 plus 0 plus 0 plus 5x3? And finally, the equation is 0.9 plus x. So I mean, reduce the variable or not? When I reduce the variable, overfitting is reduced or not? Are you understand? So what is meant by lasso? Reduce the high magnitude to 0, but ridge it not reduced to 0, but some value. This is the difference between lasso and ridge. So what exactly overfitting? If you train the model with more feature by apply the lasso regularizations, are we reduce the eliminate the feature or not? So lasso regressions also called as feature elimination technique. Remember this, guys. So lasso regressions or lasso regularizations, which is L1. So this, what exactly, guys? It reduce the coefficient to zero. It reduced the coefficient to zero. What happened? L1 also called as feature elimination. When we feature eliminate, what happened? We reduce, I mean, overfitting problem is reduced or not? Overfitting problem is reduced. Are you getting me or not? Are you understand, everyone? Okay, so overfitting problem will reduce. Online team, I hope clear, or anybody have any question, guys? Very simple. Today we started the sessions with regularizations. What is regularization does? It scale down or reduce high coefficient to low coefficient, isn't it? So there's a first thing called L2. In L2, it reduce, but it not goes to zero. It not goes up to zero. It knows come. It not goes up to zero. Okay, L1, what exactly happened, guys? It reduce, but the coefficient will go to zero, isn't it, guys? Okay. Huh? Good morning. All right, guys. So give him a big round of applause for her. How many of you see every day? How many of the faces you see every day? Uh, okay, they all are visiting. Okay, good. So, guys, online team, I have my student. All right, her name is Gopika, and she placed as Monty Corps as a junior machine learning engineers. All right, and I call her only one reason. The reason being technical. She also sitting like here, but she's a hard worker. She traveled from long distance, and statistics, when they practice a lot of time, their mindset is goes down because of some of the friends, right? Some of this is good, that is bad, this is right, that's wrong. So I wanted to tell them that 4.5 month sessions, okay, how do they come up when the mindset saying it's good, you need to go down, how do you push them up, how do they can focus on continue this one? Can you please share your journey? And I'm not calling to everyone, the students who get offers, for them only. I'm just inviting to speak up, guys. Okay. This is not time pass. Tomorrow, she also, when she study, I bring some of them. And this is what sessions, guys. So, any questions you can ask to her. Okay. Thank you, guys. I'll just 5 minutes and continue this topic next time. Okay. Thanks.
So, good morning to everyone. So, my name is Gopika Purnima. So, I'm completely from non-technical background, that is in metallurgical and materials engineering. So, I have done both BTech and MTech from in metallurgical and materials engineering, and I'm a postgraduate student from IIT Kharagpur. And so, once I have after my graduation, I, like I have journey. I started to start my journey in data science. So I have after coming to Hyderabad, I just got to know about Naresh IT, and then I have joined and so firstly, I'm very grateful to be a student of Prakash Yanapati sir, because he's the one who guided me from starting till today. His guidance, and also he helped me a lot. After the studying data science in the month of October. So I have joined in the month of October. From there, I have started learning things in data science. So yes, sir, completely new from Python to deep learning and big data. So everything is new to me. Depends on like how much time you are giving yourself to learn the things. So ultimately, this is what reflect your results. So uh, then yes, so